Welcome to our next lesson for Unit 1. Before we go on to our next lesson, we're going to do a recap of Lesson 1.3a, which was distance and midpoint in one dimension. So there was two formulas that you learned for distance, one-dimensional, which d equals the absolute value of d minus b, a minus b, or the absolute value of b minus a. Don't forget the absolute value sign because that tells you that if there's a negative number, you need to turn into a positive, because distance is measured as a positive value, not negative. And with midpoint, it's just like finding the average, but we're focusing on 2 points. So it'd be m equals, m is for midpoint, equals a plus b, or whatever two values you have, divided by 2. The midpoint is the halfway point between 2 points. It's like the average, the halfway point. So whatever segment is going to be congruent to the other segment, or whatever two lengths. All right. So distance, next lesson is distance and midpoint in 2 dimensions. So 2-dimensional. And let me try to expand. So the objective for today is how do we find distance and midpoint in 2 dimensions on the coordinate plane? So the formula for distance is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. That sounds like a mouthful. That's a lot. But this is the formula. Sorry for the background noises. Don't know what's happening, but things are popping back there. You can also write it as the Pythagorean Theorem. This comes from that. So it's c equals the square root of a squared, the square root of a squared plus b squared. Most of you might know about the Pythagorean Theorem. Most of you don't. Don't worry about it. We're going to be using it when it's needed. But this is the distance formula, so you have to try to remember it. And we're going to use examples using this formula. All right. So for So now we're going to use an example using the distance formula. They gave you the 2 points, r, which is 5, 1, and s, which is -3, -3. For the distance formula, before we do anything, we have our coordinates, x, y, x, y. To distinguish between the two of them, this will be x1, y1, and this will be x2, y2. Now we put our distance formula, which is d equals x2 minus x1 squared plus y2 minus y1 squared. Most students forget about this. They make a mistake with this, the signs. We usually put plus for that and then plus, or they make this minus, and they forget about the squares. So again, memorize it. Just memorize it. If you can find a way to remember how to write this, let me know and we could share it with the class, but just memorize. So now we have our labels, so we just plug in everything that we need. We're looking for the distance, so that's going to stay as d, and then we plug in all the information that is labeled. So we have x2, which is -3, minus x1, which is 5, and then y2 is -3, and then y1 is 1. And then we simplify. Another thing too that I've noticed, do not leave the radical sign. You bring it down all the way until you have to simplify whatever is underneath the radical. Do not make it disappear. No magic tricks with this symbol. It stays all the way until the end until you simplify. So this will come out to -8 squared plus -4 squared. Continue. Bring that symbol down, the radical symbol down. So this would be 64, and this one would be plus 16. Continue. You add those two, you'll get 80. And then You could either leave it like this, or you can simplify it further. So again, let's go here. I'm going to use another color. I'm going to put 80, the square root of 80. This is something you learned in Algebra 1. So you find two factors. One of them is going to give you a perfect square, and then one of them will give you the other factor to give you 80. So what I'm going to do is I'm going to go to my calculator. I'm going to put 80. I'm going to press y equals, and then type in 80 divided by x. And then I'm going to press second and graph, and find all my factors for 80. I'm going to see if one of the factors is a perfect square. Yep, I found 5 and 16. So 16 is going to give me a perfect square. So 5 is just a prime number. It's going to stay as is, but this is going to give me 4. And this will be square root of 5. So if I were to break it down further, simplify it, my d will equal 4 square root of 5. So if I don't ask you to give me the answer in its most simplest radical form, then you could leave it as square root of 80. If I do ask you to simplify it, then you give me the answer. Either or is the same unless there's specifications. All right. x1, same thing, using the distance formula. The first thing we do is we label our x1, x2, x1, x2, and y1, y2. This will help you, so that way you don't have numbers all over the place, because that does happen. So when you label, it makes it easy for you to place things correctly and not make silly mistakes. So we'll put the formula, x2 minus x1 squared plus y2 minus y1 squared. And then we put in all our information that we have labeled. So 5 minus negative 7. Be careful with the signs. This is where it's trying to trip you up. If there's a negative, if one of your y1, whatever values are negative, make sure you put in parentheses, because you're subtracting two numbers, whether positive or negative. And then your y2 is 2, and then y1 is negative 3, so it's going to be in parentheses. And then the square. Don't forget the square. Don't forget the radical symbol. Then we simplify. This would give us a positive number, so that would be 12 squared. And then this will give us a positive number, so then when you add those, it will be 5 squared. And this would be 144. And then this would be 25. And then we continue. So 144 plus 25 give you 169. And then this can be simplified. It gives you 13. Because 169 is a perfect square. And it gives you 13. It will give you a perfect square of 13. Alright. So now, you'll have examples where they give you 2 points and you have to find the distance and use the formula. But when they give you a graph, you could use the distance formula, but there's something else you could use. That's where the Pythagorean Theorem, which was that a square plus b squared equals c squared, or if you put it in terms of c equals the square root of a squared plus b squared, in order to solve this. So for this one, they said that find the distance between the gym and the library. So we have the gym and the library, and I'm just going to put a line. So we're looking for the distance between the gym and the library. So if you have a graph, connect the 2 points, and then you're going to find your x and your y. So your measurement going up and down, and then the horizontal measurement, left to right. So if you were to count the boxes, so 1, 2, 3, 4. So this is 4. And then 1, 2, 3, 4, 5. This is 5. You found your rise over run. So you're going to use this in the Pythagorean theorem. So remember a squared plus b squared equals c squared. And you're finding c. So this is the same as c equals the square root of a squared plus b squared. So I'm going to write the Pythagorean, this abbreviated theorem. So choose one for your a, choose one for your b. Let's say that you have a as 4 and your b as 5. So you're going to plug that in and then solve for c. C is going to represent the distance. This is your C, from the distance from the library to the gym. So you have 4 squared plus 5 squared. Continue to solve and simplify. Do not forget the radical sign. Just keep on going with that one. This will give you 41. And since 41 is a prime number, you can't do anything with it. Just leave it as is. So your C, which is also, this is your distance, is square root of 41. You could leave it as that. If I ask you for a decimal, you can give me the decimal, but make it simple. Just leave it as in that form. Less work for you. So remember, if they give you 2 points, use the distance formula, which is d equals the square root of x2 minus x1 squared plus y squared minus y2 minus y1 squared. If they give you a graph, that's where you use the rise over run. Find your rise, find your run, plug it into the Pythagorean theorem to find your distance. That makes it easier. I'm looking for efficient ways to solve a problem. All right, same thing with this one, but we're looking for the library and the cafe. So let me draw the line to connect library to the cafe. And then I'm going to find my rise over run. So my rise means you go up or down, and your run is you go left or right. So for this one, I'm going to dot. So this one is 1, 2, 3, 4, 4. And then this one is 1. So yes, we're going down. It's a negative slope, so it would be -4. But since we're dealing with distance, just leave it as 4. So again, we're using our Pythagorean theorem in terms of in terms of a and b. So it'd be c equals square root of a squared plus b squared. We're going to have a as 4 and then our b as 1. And then we're going to plug it in. So 4 squared plus 1 squared. This is 16 plus 1. C equals square root of 17, so which equals our distance. Since 17 is a prime number, we can't break it down. Just leave it as is. Oops, sorry about that. That was my phone. And let me select. And there you go. All right, now we've done distance. Now we're going to do midpoint in 2 dimensions. So with midpoint in 2 dimensions, the formula is m, which is midpoint. And since we're looking for a point, a coordinate point, so it would be mn. Again, you would think of like xy, but mn, or whatever it is. It could be AB, MN, whatever, equals x1 plus x2 over 2, comma, y1 plus y2 over 2. Remember when we did 1 dimension, where we just had 2 points, we add them and we divide? In this case, we're looking for the midpoint for the horizontal part and then the vertical part. So for this one, let's plot our points. I'm going to use this as an example. We plot the 2 endpoints. So this x1 plus x2 over 2 and y1 plus y2 over 2 represents the endpoints. This represents the midpoint. So I'm just going to write midpoint, abbreviated, and these are our endpoints. So for this one, to label it, I'll squeeze this in here. So for this one, we're going to have this as x1, y1, and then for this one, x2, y2. So I'm going to plot the points. This is 2, 6, 1, 2, 3, 4, 5, 6. And then we have negative 6. Okay, 1, 2, 3, 4, 5, 6, and negative 2 down here. All right. So we have these two, and we're looking for the midpoint between those 2 points. And I'm going to draw the line. Got this and that. So what we're going to do is we're going to plug it in. So we have m equals this, comma, put all my little symbols. All right, so we have x1 plus x2. So we got 2 plus negative 6 over 2. And y1 plus y2, so 6 plus negative 2 over 2. And then m equals, so this would come out to negative 4 over 2 over 4 over 2. And then your m will equal negative 2, 2. So if we were to find, let's see, negative 2, 2, right here. That's our midpoint. I'm going to put the m. So notice how, when you look back to the formula where we have m, which equals a coordinate point, notice how your midpoint ends up as a coordinate point, as an xy. So remember that. You're looking for a midpoint in 2 dimensions, you're going to have a coordinate point. And you just have to memorize this. This is basically taking the midpoint formula of one dimension, but you're just doing it twice. If you're doing it one for the x values, you're doing it for the y values. All right, so for this one, we're going to find the coordinates. Notice how they say coordinates of the midpoint, GH, for G and H. So again, we label x1, y1, x2, y2. And then we use our formula. So we're going to have the x1 plus x2 over 2, comma, y1 plus y2 over 2. And then we plug in our information. We have 8 plus negative 14 over 2, comma, negative 6 plus 12 over 2. Continue to simplify. This will give us negative 6 over 2, comma. Then we have 6 over 2. Continue. And I'm going to put my m. This would be negative 3, 3. And then unveil the answer. There's your answer. I don't think I unveiled the other answer. There you go. For the last example. All right. And that's our answer. Again, got to memorize it with the midpoint formula for 2 dimensions. And when you leave the answer, make sure it's in coordinate form. If you just gave me negative 3, 3, and no parentheses around it, then you just tell me that this is just 2 points. You solve for 2 points, or 2 answers. Big difference. This tells me that it's an xy. That means it's a midpoint of 2 points that were given to you, and then you have to find the middle. Same thing for this one. Let me use another color and go for blue. You got x, let's see, find the midpoint. So x1, y1, x2, y2. Find the coordinates. So we're going to have an xy. So for this one, you use the formula x1 plus x2 over 2, y1 plus y2 over 2. Plug in the information that was given and that you labeled. You have your x's and then you have your y's. And then you solve, you simplify. So this will give you 6 over 2, and then this one will give you negative 5 over 2. Let me get rid of that. It was a bit wide. And then you got m equals 3. And then if you want to leave it as a fraction, you could. Or you could just put it as a decimal. And see how I have it as a coordinate form. So if you left it as a fraction, 3 comma negative 5 over 2, that's fine. If you have it in a decimal form, that's fine too. All right, so this is the same thing. We're finding the, I'll use another color, finding the midpoint up between 2 points. So m equals the average of the two x's, the two x values, comma, then you find the average of the two y values. And then we label, always label, because then you're going to have numbers all over the place and like, how did I make that mistake? Because you didn't put the right number in the right spot. 0 plus negative 11 over 2. And then you have negative 8 plus 20 over 2. So it'll be negative 11 over 2. And then this one will be 14, 12 over 2. Again, you can leave it as a fraction. For this one, I'm going to turn it into a decimal. So it'll be negative 5.5. And then this one will be 6. And there you go. Same thing with this one. More practice. If you get the gist of it, you can go on to the next section. So use red for this one. Again, the formula. Oh, before I even do that, I'm going to label, get into the habit, and then put in our formula, x1 plus x2 over 2, comma y1 plus y2 over 2. Plug in the information that you've labeled, negative 2 plus 2 over 2, and 2 plus 8 over 2. So then this will give you 0 over 2, comma 10 over 2. 0 divided by any number gives you 0. And 10 divided by 2, 5. Select, and then you go. All right. Next example that we're doing. Not all the time they're going to give you two endpoints. They're going to give you an endpoint, and then they're going to give you a midpoint. You have to pay attention to that. So with this one, they gave you an endpoint. So this one is going to be x1, y1. Midpoint, you're just going to label it as m, comma, n. So this is not an endpoint. Remember how I said that when you go back to the formula, how these two represents the endpoints? These numbers, this represents the endpoints. This is the midpoint. Well, this is the midpoint. They're looking for that. So I'm going to put mn. So if you go back to that formula, we had m equals m n in the coordinate points. That represents the coordinate points that you have to look for the midpoint. So again, you're using the same formula. Same formula. So I'm going to write that formula there. x1 plus x2 over 2 equals y1 plus y2 over 2. So basically, you need to find x2, y2. That's what you're looking for. You have this and you have that. So how do you do this? You can split this up. So this represents, let me put it in another color. So if you want to, you can have, this is big X, and then this is big Y, if you wanted to use that. This I'm going to put as big X, big Y. So since you have one of the x's and one of the y's, we're going to split it up. So I'm going to have the big X equals x1 plus x2 over 2. And then for the big Y, I'm going to do that for the Y. So y1 plus y2 over 2. Again, you're using this formula in order to find your other endpoint. And I'm going to put the word endpoint and abbreviate it. So now you start plugging in all the information you have and what's given. So you've got your midpoint, which is the big X, which is -10. So you put -10. You have your x1, which is 9. You're looking for x2, which you do not have. So you label it as x2. And then you start doing the work. So I'm going to use another color for the work part. So this -10 is the same as -10 over 1. And then you cross multiply. So then this would come out, this would be 9 plus x2 equals -10 times 2. You keep this the same, you can't combine because you're solving for this unknown variable. This is -20. You subtract 9 on both sides, and you get x squared equals -29. So you found one of your endpoints, a piece of your missing endpoint. Now going back to the y's, because we found the x value, we're going to go and find the y. So we already have big Y, which was labeled as 5. And then we have our y1, which was 8. And we're looking for y2. Now I'm going to solve. This is the same as over 1. Cross multiply, so then 8y2 equals 5 times 2, which gives you 10. Subtract 8 on both sides. And then you get 2 as your other piece of that endpoint. Alright, so now we have to find x1, x2, y2. We already found that. And I'm going to put that, use black. So for our x2, y2, that is equal to -29 over 2. That's our other endpoint. So if you were to work to find the midpoint, to find this midpoint, if you were to use this formula and plug these in, you should come out to your answer -10, 5. So we're working backwards to find our answer. And there it is. It's very confusing. There's a lot of steps involved, but again, we're using the formula, the midpoint formula, nothing new. It's just find another way to solve for the missing pieces that we're looking for. Alright, so this one will be the same. Let me see how many we got. Alright, so I'm going to do another one. So I'm going to put the midpoint formula, x1 plus x2 over 2, so you know what we're referencing this from. And then I'm going to label. So this is going to be my big X, my big Y. This is x1 and y1. So we're looking for the other endpoint. We're looking for x2, y2. That's what we're looking for. So now again, remember how we split it up? We're going to have the big X, x1 plus x2 over 2, and then we have the big Y equals, which is the Y for the midpoint. It would be Y1 plus Y2 over 2, and then we plug it in. I'm going to use another color. So we have negative 3, and then the x1 is 2 plus x2 over 2, and then the y we have 9, and then for the y1 is 5, and then we have y2 over 2. Again, we cross multiply and use green to solve. I'm going to put over 1, the same thing. Cross multiply, so this will come out to 2 plus 2 x2 equals negative 6. Negative 3 times 2 is negative 6. Subtract 2 on both sides, and then x2 will equal negative 8. And then for this one, we cross multiply, so 5 plus y2, 9 times 2 is 18. Subtract 5 on both sides. Y2 will equal positive 13. So then our x2, y2 is negative 8, 13. And I'm going to put endpoint. Again, using the same formula, nothing new. When it comes to finding an endpoint, we just break up that formula into two sections. We're solving for the x portion, we are solving for the y portion. Okay, so we got an endpoint and we got a midpoint. And what you need to do is pay attention. Pay attention to what they're asking you, what they're giving you, and what they're asking you to find. Because most of the time, so I've seen this, don't pay attention and assume this is an endpoint. Totally, completely ignoring that this says midpoint. Pay attention. It will save you from making mistakes. So we put our formula. I'm writing this so you are recognizing where this is coming from. So we have our big X, and then x1 plus x2 over 2, and then we have our big Y, that's part of the midpoint, which is equal to y1 plus y2 over 2. Then we plug in everything that we have. We got negative 8 equals negative 7 plus x2. That's what we're looking for, over 2. And then this one is 10 equals negative 3 plus y2 is what we're also looking for. And then we solve. So this is over 1, this is over 1, same thing. 10 over 1 is the same as 10. Negative 8 over 1 is the same as negative 8. Cross multiply. Negative 8 times 2, negative 16. Add 7 on both sides. And x2 is going to equal 9, negative 9. Make that an x. Negative 9. Cross multiply. Negative 3 plus y2 equals 10 times 2, 20. Add 3 on both sides. y2 equals 23. So then our answer, so our x2, y2 that we're looking for is negative 9 and 23. In parentheses, in coordinate form. If you do not put it in coordinate form, it is not fully correct. All right, same thing. If you get the gist of it, you can go on to the next section. If you're still confused, stick around. So midpoint is big X and big Y. I'm going to put the formula so that way we know what we're dealing with. We're not dealing with anything new. We're just using what we learned. and applying it in a different way. So I got my big X, and then I put my big Y. And we plug it in. So our big X is 5, X1 is 8, and then the big Y is 2. We got 2 for the Y1, Y2 over 2. Cross multiply. I'm going to use another color to solve. I'll use red. So we got 8 plus 8 plus x2. 5 times 2, 10. And then subtract 8 on both sides. Cancel, and then we get 2 for x2. And then this one we cross multiply. This gives us 4. Subtract 4 on both, subtract 2 on both sides. Yeah. And then we get y2, and then we get 2. So then our x2, y2 is 2, 2, 2, 2. Right. So again, we're just using the midpoint formula for 2 dimensions. Pay attention to what they give you, what they're asking you to find. They said find the coordinates of an endpoint. So this endpoint would be x2, y2, even the midpoint. So they gave you the midpoint, and they gave you one of the other endpoints. So you got to pay attention. Don't always assume that every time, every question, you're going to find the midpoint. This is where they trick you up. They want to see you reading. They want to see you paying attention. All right. So now, let me see this. There's 2 examples of this. All right. So we have a graph. There'll be other times they're going to give you a graph. You're going to have to plot your points, and then you have to find. This one is the perimeter. So I'm going to plot my points. They gave me x as -2, -1. I'm going to label it so I don't get confused. And then I got 2, 5, 1, 2, 3, 4, 5, which is y. And then I got z, which is 3, 4, 3. 1, 2, 3, 4. 1, 2, 3. Z. I'm going to connect them. Line. So I got that. Got this. And I got that. So they want us to find the perimeter. Perimeter means you're adding all the sides of the shape. So now, you could use the distance formula, that d equals square root of x2 minus x1 squared plus y2 minus y1 squared. That's one way for each of them. Or you can use the Pythagorean Theorem. In this case, I'm going to use the Pythagorean Theorem. I'm going to find my rise and run for each of them. So for xy, I'm going to use this. So for this one, I got 1, 2, 3, 4, 5, 6. And this is 1, 2, 3, 4. So I'm going to use the Pythagorean Theorem. So a squared plus b squared underneath the radical. This is c, but I'm going to replace it because I'm looking for the distance for this one. So my rise over run, I can put any number. So I'm going to put 6, a for 6, 6 for a, and then 4 for b. 36 plus 16. Remember, bring down the radical sign. So this is 52. And I'm just going to leave it as 52, unless I can break this down, which I'm going to find out. See if I can make my life any easier. I look at it, I don't see anything, any purpose, so I'm going to leave it at square root is 52. So that's for xy. For the next one, yz, again, I'm going to use the Pythagorean Theorem. This represents my distance. Use the rise over run. Should have used another color. Whatever. Let's not make it ridiculous. So this one, this is 1, 2. That's 2, and this is 2. So yz square root of 2 squared plus 2 squared. So I'm going to have 4 plus 4 gives me 8. I'm just going to leave it as the square root of 8. And then I have next one, xz. Again, I'm using the Pythagorean Theorem, especially when you're dealing with graphs. And I'm going to find my rise over run for this. 1, 2, 3, 4. 1, 2, 3, 4. Yep. 1, 2, 3, 4, 5, 6. 4 and 6. And that looks similar to what we did for the first one. So I'm not going to do all that work because that's the same as that. And then they want us to find the perimeter. And then, of course, notice that they say round to the nearest tenth. So I'm going to round these to the nearest tenth. I'm going to use another color to round them to the nearest tenth. So I'm going to go to my calculator, square root, which is second, and where that x squared is, get that square root symbol, and then 52. My decimal, so round it to the nearest tenth, I got 7.21. So I'm just going to put 7.2 for this. I'm going to put approximation. This is also approximate 7.2. And then the square root of 8 gives me approximation of 2.8. So perimeter, we're going to add them all up. 7.2 plus 7.2 plus 2.8. So my perimeter of this triangle, 7.2 times 2, because it's twice, plus 2.8, gives me 17.2 as the perimeter. And select. There you go. So like I said, there's two ways to do this. You could either use what I've used, the Pythagorean Theorem, do rise over run, plug it into for A and B, and then solve. Or you can use the distance formula. Whichever is easy for you, whichever you're comfortable with, when you have to do problems like this, it's fine. Use whatever is comfortable with you. As long as you put in the right numbers in the right spot, calculate it correctly, pay attention to signs, all that stuff, you should come up to the same answer. All right, we're going to do one more. This one is, what is the perimeter of the square whose vertices? Vertices are where two lines meet. They intersect at that point. It would be the vertex for singular. Vertices is plural since there's 4 of them. So we're going to plot our points. So we got -4, 1, 2, 3, 1, 2, 3, 4, and -3. 1, 2, 3. Label. Always diagrams. Label, diagrams, draw. It helps you. So that way you have a good sense of what's going on and you're not confused. -1 and 2 and 0, -2. And I'm going to connect it since this is a square as stated. So they want to know what the perimeter is. So since this is a square, that means all the sides have to be the same. So rather than driving yourself crazy and doing more work for yourself, find one of the sides. So in this case, I'm going to find BC. I'm going to use the Pythagorean Theorem. Because this would be C equals, but since BC represents C, so I'm going to put BC for C. And then I'm going to do my rise over run. So this is 1, and this is 1, 2, 3, 4. And I'm going to plug it in. Doesn't matter which one is A or B. Just don't use one of them twice. Bring down that radical symbol. Simplify underneath the radical. All right, so then BC is square root of 17. Since there's 4 of them, but they didn't say anything about rounding to the nearest whatever, so I'm going to just round it because I'd rather have a decimal to deal with this problem. So I'm going to put square root of 17, which gives me, I'm going to put approximately 4.1. So then I'm going to, since I'm looking for the perimeter of the square, I'm going to multiply it by 4. Since this should be all the same, and it gives me 16.49, so approximately to 16.5 as my answer. Well, it says 16.4, but I rounded based on this number. So if you had this or you had that, depending on your approximation, that's fine. So yeah. So again, notice how, pay attention. You read, look for clues, because I know some of you would have tried to find all the distance for each side. Why waste your time? This square has 4 equal sides. Find one of them. Multiply by 4 and get your answer. All right. This was a long lesson. Now we're going to recap. So what we learned was the distance formula and the midpoint for two dimension. If they give you 2 points, you use this formula, d equals square root of x2 minus x1 squared plus y2 minus y1 squared. Or if you have a graph, you can use the Pythagorean Theorem. Find your rise over run, plug in your a and b, and then find your c, which represents the distance. And with midpoint, you have this formula, m equals, this is your coordinate points for the midpoint, x1 plus x2 over 2, comma, y1 plus y2 over 2. Basically, it's like the one-dimension formula for midpoint, but you're doing it for the x's, you're doing it for the y values. So these are your endpoints. Whatever they give you, these two are your endpoints. You find the midpoint based on this formula. So again, you always label and then plug it in if you have to find the midpoint. If they give you an endpoint, one endpoint and midpoint, then you're still using this formula, but you break it down to the x values and the y values. Taking it from here, plugging all the information you have. Remember how in the midpoint I made it a big X and a big Y? Place it in the right spot according to how the formula is set up, and then find your missing endpoint. So again, in this lesson, if you're confused about anything, go back, check how I did the problems. Take it slowly. If you're still confused, you can always email me, and I can always give you another example, break it down step by step for you so you can understand. Okay, so this concludes our lesson, and see you next time.